All right, my name is Luke Natty, and this is my Lab 2 presentation for observing line charges on the tapes. So for the table of contents, we have our introduction, our data and observations, code, discussion, and conclusion. So introduction, the purpose and fundamental principles at play. This lab serves the purpose of being a more in-depth look at how neutral objects polarize and have interacting charges. The experiment from Lab 1 is used again, but the model allows for a closer look at how individual particles in the tape have charges that interact. The principle at play is Coulomb's law, which observes the interaction of electrical charges. This is a more in-depth look at the same experiment from Lab 1, where we took two charged tapes and observed their repelling against each other. But this time, we're dividing it up in the coding model into point charges so we can see how those point charges interact as a line of charge rather than just one point charge for the tape. In a preview of the results, each particle on the tape experiences different electrical forces due to the distance of the particles are from the other particles on the other tape. They are also influenced by other particles which change the direction and force on them. So Coulomb's law states that the magnitudes of charges influence the repulsion or attractive ability of the charges depending on the magnitude of the distance between the charges. Now this makes a difference, especially when you have line charges, because for point charges, the distance is just the center of the charge to the center of another charge. For line charges, the distance could be across the entire object distance, or they could be right next to each other. So it influences the way the charges interact. So for the experimental model, same thing as last time. We had two pieces of tape. The top tape was the system. The bottom tape was the surroundings. The tape masses were 1.02 times 10 to the negative fourth grams. Length was 0.15 meters. Width was 0.02 meters. And the tape was a distance 0.033 meters away from each other. For code, here's my code. I took the code that I had from Lab 1 and I altered it in order to reflect the different charges on the line rather than certain point charges. So you can see that we have a function for line charges, which will intake information about where the point charges are on the line, and then intake all of the electric field information from the point charges that are interacting with it in order to create a central magnitude charge. Instead of outputting every single charge that interacts with it, we'll just have the magnitude of the combined force on this charge through the principle of superposition. And then the other section of code all looks at how I established the arrows and model, looking at how I established the point charges in the line charge, while also establishing arrows to represent force. So moving into the model, this is our model right here. We have the red operating as tape B, the purple operating as tape A. So you can see that gravity is the yellow arrow, which is pulling down on the top piece of tape. But there are multiple electrical forces on each point charge, which are the white arrows pointing up. And those are the repulsion charges that are found between the two charged pieces of tape. So finding the electrical force, which is what our model was programmed to do, and then reworking the equation, you can solve for Q, which would be the charge of the original tape. And I solved that out to be 1.73 times 10 to the negative 8th coulombs. And there were some assumptions that we had to make when solving for this. And in this case, the tape was treated like a cluster of point charges. So that way it would be easier to actually find what the charge on the overall tape was. So for discussion, what if the tapes were both treated as point charges, the overall magnitude of the charge would be greater since the charges would not be distributed between the length of the tape. The point charge calculated number was 1.01 times 10 to the negative 8th compared to 1.73 times 10 to the negative 8th. This is because the point charge is ultimately going to be different because the distance is changed between the charges instead of it being spread out over the point charges. And why these estimates differ because the charges are not separated between the total length of the tape. Distance interferes with the strength of the charge according to Coulomb's law, so the forces would be different for 2 point charges than for 2 line charges because the line charges have different distances at play, ruling out overall magnitudes in like the X direction and then ultimately putting a Y direction as in comparison to 2 point charges in line. Thank you.